And once again, the calendar is ready to flip to a new astronomical season. In this case, of course, it's winter on Saturday, and that means it's a good time to welcome in, or welcome back, our good friend and resident astronomer, Dr. Chris Palma, from the Penn State Department of Astronomy and Astrophysics, also now Associate Dean in the Eberly College of Science. It's good to see you again, Chris. So what was your first full semester as an Associate Dean like?
It was fun. Big change, right?
Yeah.
But I think, you know, what I really love is I love teaching astronomy. I love talking about astronomy. I hope that's obvious, but I really love working with our students.
Yeah.
So spending a semester as 100% of my focus could be on the students in the college has been a blast.
Well, good to have you as an Associate Dean there. I thought we could start with a little bit of planetary, actually a tidbit. I used this as an extra credit question in one of my media classes. The idea that the closest planet to Earth at any given time can actually be either Mercury, Venus, or Mars, and it's most frequently Mercury, which surprised a lot of my students. And this all wraps into sort of the planetary dynamics.
Yes.
And give us your view on that.
I'm going to start in a way you might not be thinking about, but you've all probably heard there's no gravity in space. Like as soon as you see astronauts, you think of, oh, they're weightless. But one of the frustrating things for us in teaching astronomy, there is gravity in space, right? And we know that because it's the gravity from the sun that pulls on the planets. So Mercury being the closest planet is moving fastest, Venus a little bit slower, Earth a little bit slower, Mars a little bit slower. So Venus spends a good amount of its time on the opposite side of the sun, moving more slowly. Mercury zips around, so in fact it does spend more time on the side of the sun close to us.
Yeah, it was interesting. Only a couple of my students got that right because I think there's the perception that it's probably Venus and maybe Mars and nobody thinks about Mercury. There's always interesting work coming out of your department. Recently I noticed something about cloaked black holes, and this gives us some insight into the early time of the universe. I mean, how does that work?
Yeah, I want to start off talking about the distances to these things, right? So if you think about the sun, we hear all the time the light from the sun took 8 minutes to get to us. The light from these distant objects took billions of years to get to us. So we're seeing them as they were billions of years ago, and all that time ago, they were surrounded by these clouds of dust and gas. And so light can't get through those clouds. And so you might think X-rays, well, X-rays can go through us. Surely X-rays can get through a cloud of dust and gas, but some X-rays get absorbed. And so there are lots of very distant objects that we can't see because all of the light is being absorbed by those clouds of dust and gas. We got 3 particles of light through one of those clouds, allowing us to detect one of the most distant and earliest black holes to form in the universe.
And it's crazy to think about how when that light finally gets here, you're looking back in time, billions of years.
Billions of years.
With the holidays upon us, any tips or suggestions on maybe last-minute gifts for the astronomy buff in the family?
So I think we might have talked about this a little bit, so I want to give my favorite tips. So one, if you're thinking about a telescope for someone you love, think about binoculars, right? So binoculars are really good for looking at the moon, for looking at planets. The hardest thing about binoculars is being able to hold them steady, but I really don't want people to forget that that's an option. And then the other thing I would say is if you really want a telescope, budget a little bit more. The cheapest telescopes often have plastic lenses and they're not very stable. A good telescope for around $100, $150 is much more often going to have a glass mirror with a very sturdy base. And so those are what I would recommend.
Gotcha. And you know, when it comes to sky watching, I mean, right now, I guess there's quite a show going on with 2 planets getting really close to one another.
Yeah. So we're really fortunate at this time of year. There's been a bunch of planets in the sky. We've been able to see Jupiter for months now, Saturn, and now Venus. And coming back to our first question, right? So Venus moves relatively quickly, Saturn moves slowly. So what's happened is Venus has caught up, kissed Saturn, and now it's passing by. And so right now, if you go out, you're going to see Venus and Saturn quite close to each other in the sky.
And this would be in the evening, shortly after sunset.
Mm-hmm.
And somewhat related to that idea, a question that I know you get this time of year involves the story of the Star of Bethlehem and whether there's a scientific explanation for what that could have been. I mean, what are some of the theories?
Well, it goes right back to Venus and Saturn being right in the sky right now. So that alignment between those two planets is called a conjunction. You have two planets right next to each other in the sky, and it really draws your eye. So one of the things people have said, were there conjunctions of bright planets that would have happened at the right historical time of the story of the Star of Bethlehem? And in fact, early on, a couple years BCE, there were a number of what are called either planetary conjunctions or planetary massings, where you have Jupiter, Venus, Saturn all in one part of the sky. That's probably the most commonly assumed possibility for what could have been the Star of Bethlehem. So not a star after all,
right,
but a group of planets.
Right, and I mean, after all, the brightest objects in the sky, other than the sun, are planets.
Yep.
Right. Dr. Chris Palma, Penn State Department of Astronomy and Astrophysics, and Associate Dean in the Eberly College of Science. Always a pleasure to have you.
Thank you.
Have a great winter. We'll see you again in a couple months. And we will be back in a moment with a recap of the short-range forecast.